Our presenter today is Scott Register, Senior Director, Product Management at Ixia. I know you have a lot to cover today, Scott, so let's just dive in.
Okay, sure. Thanks for joining us today. Again, my name is Scott Register, and I run one of the product management teams here at Ixia, and I'm primarily responsible for applications and security. So we do a lot of work on the visibility side in enhancing application visibility, understanding application performance, improving network security. And a lot of our presentation today will be focused on how we're leveraging these technologies and this research to help our customers manage their networks better. Okay, so one of the clear trends in networking, over the last few years and continuing certainly into the foreseeable future is the tremendous growth in just internet traffic and traffic between companies in the internet, between multiple data centers, between the internet and data centers, and there's a huge growth in intra-data center communication. That's primarily east-west, let's say between VMs. But in general, communication is growing, and you know this because you've been upgrading your internet links, and you've been upgrading your internal speeds from 1 to 10, sometimes to 40, and now even to 100 gig links. And so you've seen firsthand this demand for ever increasing bandwidth. But even though that's kind of good for users and that they can move their data around faster and they can deliver their apps faster and they can load whatever it is they need to load much more quickly, this presents a lot of challenges. Primarily, if you're trying to perform like troubleshooting to figure out why an app isn't performing the way that you think it should, or you want to look inside all of that data to see indicators of compromise or spot malicious activity or someone trying to break into your network, or even you're trying to guarantee application performance for your users, it can be quite difficult. I mean, it's quite literally finding a needle in a haystack, trying to track down a small piece of data to figure out, hey, why can't this user read email, or why is this application running slowly? And that's really the primary goal of network visibility solutions is trying to pour through all of this data and get you exactly the information that you need at exactly the right time, and then typically deliver it to a particular analysis or security or troubleshooting tool, so that those tools can make sense of all that data, and specifically by kind of narrowing it down just to focus on what they need. And there are three primary ways that sort of narrowing down is done. The first is by filtering. And that's really just saying, okay, I've got this mountain of data out there, but I'm only interested in a certain application or a certain network or a certain VLAN. But basically it's specifying some criteria and saying, okay, ignore everything else. I'm just interested in this particular slice of what's going on. Traffic grooming, this is saying, okay, I want, not only have I picked a particular subset of traffic that I'm interested in, but I want to process it in some way because the traffic as it comes off the network isn't appropriate, isn't suitable, whatever, for my analysis tools. And so I have to modify it in transit to better use my tools. An example might be timestamping. It's your tool needs to know exactly when different packets arrive so that it can make sure that it's analyzing packet sequences in the correct order. And a third way, and this is, I won't say it's a new trend, but there's certainly a lot of work done here, and there's a lot of kind of analysis industry springing up around this, is by summarizing data. So instead of sending every byte of data that moves across the network, maybe you just need sort of summary records of events or metadata, and you can do your analysis based on that rather than having to get all of the raw packet data. So an example of how we do the first part with filtering And this is just the UI from an Ixia NTO. That's a net tool optimizer. And there are certainly other, this is a representative kind of sample, and frankly, our UI is pretty nice. But there are other kinds of tools that can let you accomplish some of the same basic filtering capabilities. For instance, you might say, I want to look at only traffic that either meets certain criteria or traffic that doesn't meet certain criteria. And you can look at typically layer 2 through 4 kinds of criteria. So you might want to specify a particular MAC address so that you could focus on a particular, could be host, could be a router, or something like that. You might want to look at a particular IP address or maybe even transactions between two hosts. So you specify 2 endpoint IP addresses and say, okay, I'm only interested in looking at communication between those two. Or you want to look for maybe it's certain packet headers. Like I'm interested in doing some very specific troubleshooting, and I only want to see TCP packets where the urgent bit is set. So this kind of layer 2 through 4 filtering is really the foundation of certainly what we think of as network packet brokers, which let you specify a subset of traffic going across the network to let you do really the first pass of narrowing down kind of all of that mass of traffic to just the data that you are interested in. Now, something that we have been working on a lot recently is doing more application-based filtering. And the reason that you do this is there may be things like multiple applications running on the same TCP port. A great example is web apps, right? So you might want Facebook but not LinkedIn, or you might want, some particular, it could be Microsoft Office, but, whatever it is, there's some particular application that's running, and it's running a report that's shared with lots of other applications, and you're interested in just seeing that. You want to maybe exclude YouTube traffic. You want to see Facebook. You're interested in Dropbox because you want to see when your internal users are saving data out on the external network. Well, all of these applications and zillions more, these are all web apps, right? So you'll see port 80, you'll see port 443 if it's encrypted. If you have an analysis tool that's really focusing on a particular application, you want the ability to pick just that app, like just Facebook, and send only that to your analysis tool. One of the other things that we found particularly useful, sometimes for troubleshooting and sometimes for applications like lawful intercept, is being able to specify regular expressions. So if you want to look for a particular email address or maybe a credit card number or something like that, you can look inside the application stream and pull that out. So now let's talk about packet grooming. And this is where you manipulate individual packets between the production network and your analysis tool so that they're sort of better suited for analysis by that tool. You might have an analysis tool that, let's say, only wants to see the packet headers, right? Because it has limited bandwidth, it doesn't really care about payload. Or maybe there's extra headers on a packet that your tools can't deal with. And when you send that sort of extra information to your tools, they become sad because they don't know how to deal with that information. And they're either overloaded or they're confused because they say, hey, there's these extra bits on this packet, I don't know what to do with those. So packet slicing means you set some boundary in the packet. It's typically after the header and might be 64 bytes into the payload. It might be 8 bytes into the payload. But you're basically saying what for the purposes of this particular analysis tool, if I can see the headers or the headers in just the first couple of bytes of payload, that's all that I need. And so we can just slice that packet in half or whatever boundary you set so that that analysis tool is only getting that subset of data that's useful to it. And so you're reducing the bandwidth demand going into that tool. That's very important as network speeds increase because typically network speeds grow faster than processor speeds, right? I mean, that fact has been true for a long time. That's why we have load balancers. And so a lot of times your analysis tools won't quadruple in speed just because your network has moved from 10 gig to 40 gig. So if you can reduce the bandwidth that's going into that analysis tool, then you win, right? Because you're getting the data that you need and not overwhelming your tool. In similar fashion, when you do header stripping, that's removing some part of the packet, typically not just for bandwidth saving, but because the tool doesn't know how to deal with it. For instance, I've seen a lot of analysis tools that don't know how to deal with VLAN tags. They just don't have a parser set up for that. And so again, if you send a packet with that tag on it to your tool, it becomes unhappy. So if you strip that tag off, or if you've got, packet sending extra information, if you slice that packet in half, then your tools become happy again, and they're doing the job that they need to do. So one of the most popular individual features that we see, like getting sort of packaged with our packet brokers, and certainly comes up a lot in the industry, is something called deduplication. So at the packet level, it is quite common for analysis tools to get multiple copies of an individual packet unless you do something about it. Now, there are two primary reasons this would occur. The first is if you are accessing span ports in your network. You've got switches set up and you're plugging analysis tools maybe directly into those span ports. Because of the way the span ports are programmed, you will also often see a packet like sort of when it comes in on a link and when it goes out on a link. That's a really common way to see it. And so that means you're forwarding multiple copies of that packet to your analysis tool. Another way that this can happen is if you're using taps in your network, you are probably tapping lots of segments, and it's certainly common to see a packet leave one host, go across multiple hops in the network, and then go to its final destination. Well, if you're tapping each of those links, you will see that same packet every time as it traverses across the network. But that information is probably not useful to your analysis tool. You don't want your tool to interpret the multiple appearances of that packet as, let's say, a retransmission, which it's not, and you don't want to sort of get a false positive on errors. Then going back to the bandwidth issue, there's no valid reason for duplicate copies of a packet to be sent to an analysis tool. So if you're tapping 4 network hops, you see the same packet all 4 times, you can cut down on the bandwidth going to that tool by 75% just by removing duplicate packets from the stream. And that's, again, this is perhaps the most common kind of packet grooming that we see that lets you reduce the load on those tools. So now let's move on to the last point that we discussed in how to sort of reduce traffic, and that's the use of metadata. This means summarizing connections. Quick example of this, you could either read War and Peace if you've got a couple of weeks to spare, and maybe that's great information, but for purposes of your recording how popular different books are in your network, if somebody just says, hey, Ralph read War and Peace, that's enough. That's all that you need, and there's no reason for you to read the entire book. Another analogy on networks might be there's a lot of Netflix and YouTube traffic. You don't need to send typically that traffic to your monitoring tools, either for performance analysis or for like troubleshooting or typically even security. You don't have to send all of the data, let's say from a Netflix connection, as long as you know that someone in your network connected to Netflix and consumed 4 gigabytes of data over the course of 2 hours. So if I can send you a single packet that has that summary information, and I don't have to forward the entire movie to you, but again, you win. You're limiting the bandwidth demands on your analysis tool because you're giving them the relevant information that they need to do performance monitoring and understand your network usage without overloading them. That's typically done in networks via the use of NetFlow. Now, at Ixia, one of the things that, again, we've focused on is sending not just NetFlow data, but trying to make that NetFlow message, that summary message, as useful as possible. And we've done that by adding a lot of interesting context or interesting metadata to our messages. So we'll tell you not just that a connection lasted a certain amount of time, but exactly what application it is. We have a built-in DPI engine, and you can say, oh, this wasn't just port 80 traffic, this was Netflix, or this was Facebook, or this was LinkedIn, or Dropbox, or whatever the app is, and also telling you information about the end user, things like what kind of handset did the user have, what's their browser type, that kind of thing, so that when you're trying to do troubleshooting or security analysis, you've got a lot more information than just bandwidth utilization to really help you understand the context of a connection. And that's critical for understanding, is the connection good or bad? Is it something you need to worry about? Is there a problem you need to fix? Or everything's fine and you're just monitoring usage. We also find that in many networks, asking the routers or switches to perform NetFlow generation produces significant CPU load on those devices. And so we've implemented our NetFlow generation in a way that not only is it application aware and it has all these application intelligence features, but we'll let you offload that generation from your devices. So when we send our NetFlow messages, they can look just like they came from your network infrastructure devices down to the interface, direction, and the device ID, which is the ODID. So you can emulate all of that on our network tool optimizers so that it's a very seamless transition for your monitoring tools. You don't have to adapt them. You don't have to reconfigure them because it looks like the messages are all still coming from the same place. They're just more intelligent now. So some of the enhancements, just to go into a little more detail, in addition to the standard, how long did a connection last, how many bytes was it, what was the IP address and port number, we'll also show you things like what's the, what specific apps are in use. And this is true down to the application sub-actions. So in a streaming media example, maybe you want to know not just that people listen to, Pandora, but you want to see when people hit pause and skip and fast forward and create new station. We'll report on all of that kind of information as well. What was the browser type? What's your distribution of users? And then you can correlate that in your analysis tool and say, oh, users of a particular app are more likely to use IE, and a different app, people are more likely to use Chrome. And so maybe if you need to understand what browsers you need to support in your environment, we give you the basic information that you need to make that decision. Handset type or device type. If you want to see how many of your application users are on mobile devices versus PC versus Mac, again, all of that information is provided not only in our dashboard, but on a per connection basis in the NetFlow messages. So you can see, 20% of my users are on iPad, and the ones in Austin, Texas, with a certain service provider are having problems, right? Because they'll also report service provider information. So you can correlate all of that data and quickly resolve, hey, I see a problem and it's consistent across a certain platform or a certain geography or even a certain service provider. And we can do that worldwide for both public and private IPs. So you can see, where information is going when it leaves your network. Hey, I see a file transfer connection going from inside my network to, North Korea might be an interesting thing to know about. Again, we're giving you this in both summary form, sort of on screen, and reporting it on a per connection basis over NetFlow. So SSL, this more and more data on the network is encrypted, and that's both good and bad data. So I pulled some stats here from Sandvine and Gartner showing sort of the rise of good and bad SSL traffic. SSL is great for authenticating and securing your connection. You want to make sure that nobody is reading your sensitive data in transit. Then, of course, you want to encrypt it, right? Turns out malware is often sent inside SSL, either by design or just because it's sort of embedded in some connection. this causes a problem for you if you're trying to do security analysis. Even if you're just trying to monitor application performance or do troubleshooting, again, encryption can pose a serious challenge, because if you don't have a way to deal with that encryption, then basically you can't see what's going on, right? You're fumbling around in the dark. All you see is, hey, here's traffic on port 443. I have no idea what's in it. I'm pretty powerless to do anything about it, to understand what the risks are, to understand if my application is behaving well or poorly. And so one of the recent introductions, again, that we have made, and certainly something that you will want to consider in your network, is how to deal with encrypted traffic. So we now offer, as part of our ATI processor, included with the subscription, we offer decryption. So you can just import keys, certificates, and private keys onto your network. Your NetTool optimizer will decrypt the connections in transit passively, so we don't impact an original connection. And then you get all of the application intelligence pieces that I referenced earlier, all the things you need, like the summary data, the NetFlow, the understanding application usage and handset type, and all of those other context pieces. You can apply all of that to encrypted communications. This is really important inside the network, because increasingly more and more, again, of that internal traffic is encrypted, and so you want to be able to pull information from your internal servers when they talk to each other, so that you can understand, let's say when there's a spread of malware in your network. If there's VM to VM traffic and it's encrypted, we offer a combination of virtual taps and decryption that let you pull that traffic out, see what applications are running, look for hidden threats, look for a spread of malware, look for attackers moving around inside your network, not just at the internet gateway. We make it pretty easy to import certificates and keys, so literally you can copy and paste, you can import common file formats, things like that. So the real reason, again, for doing this SSL decryption is so that you can perform you can gain application intelligence. You can get this application level insight and summary data and application forwarding and things like that, even if your data is encrypted. And we make it, frankly, pretty easy. There's just a little checkbox that you see here for forward encrypted traffic only. You pick the geography, the applications you're interested in. We'll pick up those off the network when they're encrypted, decrypt them, and forward that traffic out to your analysis tools. So one of the things that we've also found, that when you're dealing with data that was originally encrypted, and so you have to decrypt it and forward it on, the kind of tool that you use to do that decryption has a big impact on how efficient you can be when you're trying to understand what's going on in your network. We placed a high emphasis on making sure that the decrypted output was stateful, meaning it's got full TCP handshake and correct sequence numbers and acknowledgement numbers and things like that, so that if you are using an analysis tool, and here I'm using Wireshark, which is a common example, but this is certainly true for everything from IPSs to application performance monitors, we make sure that output can easily be understood, that it doesn't look different. It looks like something that was clear text and a completely valid connection. So when you bring it up in something like Wireshark, here is the example, it looks completely like a valid connection. There's no missing packets, there's no wrong sequence numbers, things like that, so that when you're looking for errors, anything that you see reported as an error is an actual application error and not just a byproduct of the decryption happening. So getting back to that virtualization message, and if you think back to the first real slide in the presentation, we saw that data on the internet growing very rapidly. User to data center traffic is growing fast. Inter-data center traffic has recently started to pop up. This is things that a user doesn't touch. It's just two data centers communicating. But by far, in terms of overall growth and proportional growth, east-west traffic or intra-data center communication is growing the most rapidly, and in terms of proportion, is basically going to consume all of the others in terms of sort of overall share. That presents a real challenge in terms of monitoring, because so now you've got all these VMs in the network, you've got all these systems talking to each other. Most of them are virtualized, certainly if you have kind of a cloud center. How do you gain insight? How do you get application level information? How do you do all that kind of filtering and processing for that east-west kind of traffic? So this is why we provide a virtual tap, which functionally is very much like a physical tap, except that instead of being on a physical network link, it's plugged into a hypervisor. So if you want to see all the traffic from a particular VM or relating to a certain application, or you want to see exactly what's contained in communication when two VMs talk to each other, you can just plug this virtual tap in, and we will pull all of that information out, whatever subset of that you're interested in, send it over a GRE tunnel to our NetTool optimizer. And so there we can do all the same kind of analysis that I've been talking about, even if that traffic was virtual source. Make it pretty easy. Literally just kind of set an IP address on your NetTool optimizer. All the virtual traffic goes there. And then you can treat it just like physical source traffic, so it's a nice, seamless approach, no change in UIs, things like that. And this even works with SSL. So even if that VM-to-VM communication is encrypted, and again, could be a bad guy moving stuff around, could be just standard application traffic, you can take that traffic out of your pure east-west VM-to-VM world, send it to your NetTool optimizer, and then process it just as you would any other traffic. So I wanted to show a couple of demos, so we'll go through two quickly here. And this is actually based, this example is based on an example or a use case at one of our customers. And they had a requirement that all of their internal email should be encrypted using secure SMTP, which completely makes sense. That's a common requirement, right, is that all sensitive internal data is encrypted. But it was a very large network, and it was hard for them to track down individual mail servers that didn't have encryption turned on. And so using Ixia's ATI processor and the application-level intelligence, they were able to quickly see that clear text versus encrypted traffic in their network so that they could go talk to the system administrators and track it down. So to show you how that would work, first, I can figure out how to, there, sorry. Okay, so first, I will come up and say it's time to create a new filter. And from my list of applications, I'm going to pick secure SMTP. So I can just do a text string and pick SMTPS, which is SMTP secure. And for this traffic, I just want the NetFlow information. I just want summary data for that, because I don't really care about the packet data, because this is behaving as it should. So that takes care of that. Now I want to grab all of my clear text SMTP traffic, and when I see standard mail traffic on the network, instead of just getting summary data, I want to forward the actual traffic out a tool on my packet broker and send it to an analysis tool. So once that's done, I'll just save the filter under whatever name I want. Once this filter is set up, then anytime clear text SMTP traffic occurs on the network, not only will I see it reported on my dashboard here, it will be sent out to that external analysis tool in complete clear text every single packet. So now I can just do maybe a data capture with our built-in packet recording, or I can send it to some external RShark box or something like that. I can record all that data. I can see not only the IP address, but who was the email to and from, what's the content. I can be sure that the information that was sent over clear text didn't create any exposures, etc. So that was really easy to do. I just set up two filters, one for secure SMTP, just to do NetFlow reporting, so I can see how much of that is going on, and then one to forward the actual application data for the clear text connections. Now, another example might be for sort of policy compliance. You want to see when people are maybe using Dropbox from the inside of your network going out and storing sensitive data externally. So here, again, I just come over and say I want to create a new filter. In this case, I can pick the specific Dropbox applications that I'm interested in. Select this and the user content. So I'll accept those. And now I can pick, do I want to forward that traffic, or I just want summary NetFlow reporting? What collector do I send it to? I save that. And now anytime there is Dropbox traffic on my network going to the outside, I will see it again reported on my real-time dashboard. Down at the bottom, it would just show up under the filters here, but also complete information about that connection is sent to my analysis tool. So everything from IP address to, is this coming from someone's PC, or is it coming from their iPad, or is it coming from their tablet, how much data was sent, et cetera. I can pull all of that data out in my analysis tool, and it could be, Plixer or Savius or Splunk. There's plenty of tools out there that will consume that NetFlow and let you do reporting around that and understand what risks may have been created on your network by the use of those external storage services. Okay, that wraps up the presentation, and we have time, I think, for a few questions.
And we've had some come in. So the first one is, how do you tell the difference between different applications running on the same port, like different web apps?
Oh, okay, yeah, so I might not have been clear there. So we actually have our own DPI engine. One of the technology companies that Ixia acquired a few years ago was a company called Breaking Point, which focused on very realistic application and security testing. And so Breaking Point had built an engine that let it produce very, very accurate application traffic using real text in your choice of languages, and you could, actually log into Facebook and send Twitter messages and things like that. So we basically took that engine and sort of turned it on its head, and so now instead of doing application generation, it's doing detection and classification. And we took that engine and we built it into our NTO platform in what we call the ATI processor. That's the Application and Threat Intelligence processor. So that processor includes basically that breaking point technology, which lets us do app detection and classification.
What's the sampling rate of your NetFlow tool?
Oh, yeah. So we do unsampled NetFlow currently because we're really focused more on performance and making sure that external tools get all they need. What we found is that when you're doing security analysis, it's really important to have unsampled NetFlow. If you're doing performance monitoring and kind of general network management and performance tracking, sampled NetFlow is fine, and we'll probably implement something that lets you enable that down the line. But right now, we're really focused on unsampled NetFlow to better support security applications.
Do other services slow down when you turn on deduplication?
No. The way that we've implemented those packet grooming features, there's basically a dedicated per port kind of processing pipeline. It's a lot of P's. And so when traffic goes through there, there's a staged approach that can turn on all of these features without slowing anything down, right? So you get full line rate performance for doing deduplication and timestamping and header stripping and packet slicing and all of those other things. And what's happening on one port doesn't have any kind of impact on what's happening on any other. So turning on a feature like that doesn't impact performance on that port or anywhere else in the system.
Can you use the Ixia application intelligence pieces for security, or are they mainly for troubleshooting?
They're certainly used for both. Like I said, I mentioned the unsampled NetFlow earlier, but you might be interested in, we're not an IPS, but you might want to focus on certain applications that you think are suspicious. I didn't really go into it today, but one of the interesting applications for application intelligence is seeing when new apps that you don't know about or maybe don't expect pop up on your network. It's from a security perspective, it's the 99 things that you expect are probably not the problem. It's the one thing that you weren't expecting that you really want to be interested in. And so we'll classify those new apps popping up on your network and let you pick just those out for analysis. So that's certainly a common kind of security application for the API processor.
How often do you add new applications for filtering, and can I add my own?
It's every couple of weeks we have an update for ATIP, which includes things like new application signatures, new geolocation updates, things like that. And we do support what we call custom apps. There's just an XML template that lets you define an application. And actually, when we see something new and unknown on the network, we sort of pre-populate a template for that based on whatever we've been able to learn about the application, just watching it on the network. You can actually download that signature, edit it, and then re-upload. So you can write your own apps, but you don't have to start from scratch when you do that.
Well, thanks, Scott, and thank you all for attending today's webinar. In the event you wish to view this webinar on demand or download previous Tech Talk Live webinars, you can do so by visiting the Ixia channel on Bright Talk. And you'll also see on this last slide Scott's Twitter handle and his email. So if you have questions that didn't get answered today, know that we'll follow up with you via email.
Yes, absolutely.
Thanks,
Please feel free to contact me. All right, thank you. Thanks, everyone. Bye.
Bye.